Hi, my name is Babs, and I will show you how to make an artificial muscle from a fishing line. The following experiments are based on the work of Carter Haynes et al. You need for this experiment a few special things. An experimental setup with a hole for the drilling machine. And also a power supply with crocodile clamps, a temperature sensor. For the measurement of the muscle's contraction, you need one breadboard, some jumper wires, an op-amp, electrical resistor, and a flex sensor. The flex sensor is for measuring the contraction of the muscle. A non-contact revolution counter with a magnetic sensor. For the data collection, I used a Raspberry Pi, an amplifier for thermocouple, and an AD converter. One monitor and a keyboard, fishing lines and paper clips, and a silver-coated nylon thread. Some weights. Cut off about 80 centimeters from the fishing line and attach the paper clips. Attach one end to the drilling machine and the other end to the weight. Add all the pieces together. At first, I produce a muscle with the drilling machine. The ref counter counts the windings about 800 to 1000 for this length. Here you can see the coiling of the muscle. Coiling reduces the fishing line's length. That's a just produced muscle. For electric heating, a silver-coated nylon thread is wrapped around the muscle. Electric current is sent through the conductive nylon thread and heats up the muscle. Finding the right weight is important for the contraction. Now I switch on the power supply to start the electric heating. With the proper weight attached, the muscle contracts by about 20%. Now the heating has been stopped, and the weight moves back to its initial position. The flex sensor, which is fixed to the weight, sends the signal to the Raspberry Pi. Let us have a view at my overall experimental setup. The camera follows the cable of the temperature sensor. The transferred data are recorded and displayed on the monitor. Both muscle temperature and contraction are recorded. In this experiment, the muscle broke. But here it works properly. The muscle contracted by 3 centimeters. The data of the just performed experiment is illustrated. First, you see the temperature and the contraction history, and the green curve represents the specific power rendered by the muscle. These artificial muscles build cheap and efficient actuators for future robotics and prosthetics.